All right, so you should have already checked the homework from the other day, but we're going to practice a few more. We're going to do a few more together. I've got my notes that we've done, and there will be another video for the notes. This is only one side, so we're going to do 3 together. In the end, this will be your homework, this entire page. But keep in mind, you still have another video to watch and practice that is included in the video for another handout. So don't spend all of your time here. You might end up having some homework. So the first thing in our steps is multiply or divide. If this were the situation, this is not happening at all on this page, so I can skip that. We don't have any fractions, so I'm skipping rule or step 2, but I will be doing step 3 and making a factor tree. So I'm going to go over here. Let's just start with the first one. This is a cube root, 128, and I'm just going to start breaking this down. So for instance, I know 2 goes into it, and then 64, and then I'm going to break 64 down into 8 and 8. I'm going to break those 8s down into 4 and 2, and then those 4s can break down. So when I'm done, I have a lot of 2s. I circle them so I can count them. So the first thing I'm going to do is rewrite this, and instead of 128, I have 1, 2, 3, 4, 5, 6, 7 2s. So I'm going to write it as 2 to the 7th. And then I have the x to the 4th and the y to the 2nd. And now what we're going to do is, rule number 4 is not happening. We don't have any radicals in the denominator. Denominators are from fractions. So we're going to go to step number 5, which says rule number 3, nothing may be perfect under the radical. We're going to take out the perfect stuff. So when we did this, I made a perfect and a not perfect. And I'm going to start taking out as many as I can. So of these 7 2s, 6 of them are perfect and 1 is not. I still have my 7 2s, but I've split them up. And we talked about that we want a number that this can go into perfectly, and 3 can go into 6. And again, I want as many of the 2s over here as possible. So of the 4 x's, 3 of them are perfect and 1's not. And of the y's, none of them are perfect. I don't have enough, so they're going to stay here. So now I'm going to take out the perfect stuff. The 2 is going to come out and the x is going to come out. And now I'm going to see how many 2's and x's I have. So I use the division trick. 3 goes into 6 2 times. 3 goes into 3 1 time. You don't have to put the 1, but you can. And then I still have, I'm going to separate it out so it doesn't look all mushed together. I still have a 2, an x, and a y squared. Now this 2 squared, that's fine. You could leave it as 2 squared, but it would be better if you changed it into 4. So having that as my answer. And I'm fine if you just cross it off and write it next to it. You don't have to rewrite the whole thing. So let's take a look at number 5. Number 5 is another cube root. Again, I don't have to do step 1. I don't have to do step 2. I'm going straight to step 3. I'm making a factor tree of my coefficient. So 27 can break down into 9 and 3, and then 9 can break down into 3 and 3. So I'm going to rewrite 27 as 3 to the 3rd power and all the other stuff. And now I'm going to make my perfect and my not perfect. So of the 3's, they are all perfect. Of my x's, 3 are perfect and 1 isn't. And there's only one y, so it is not perfect. It has to stay in here. So now I'm going to take out the perfect stuff. I'm going to take out the 3 and the x, and now I'll see how many 3's and how many x's I have. So 3 goes into 3 1 time. I'm not going to write it this time. 3 goes into 3 1 time. Won't write it. So, and then over here is the not perfect, and I have that one. So let's do one more. Let's do number 9. Let's do a 4th root, and then I would suggest you spend maybe about 10 more minutes on this and then move on. Okay, so note the time and 10 more minutes because I need for you to get through the other video and get some practice. All right, so again, my steps, I don't have to do it. I don't have to do it. I'm going to make the factor tree. So factor tree of 48. I'm going to do 6 and 8, and 6 will break down into 2 and 3, 4 and 2, 2 and 2. Remember, you can pause. I know I'm going a little fast, but it's because you can pause this. So I'm going to rewrite this as 1, 2, 3, 2 to the 4th. I have a 3, and then all the other stuff. And it's kind of hard. I changed that z into a z to the 12th. So now I'm going to make my perfect and my not perfect. And now I'm going to take everything out that's perfect. So of these 2's, they're all perfect. The 3, I'll put a power to it. There aren't enough 3's, so they're going to go over here. My X's, I don't have enough. My Y's, I don't have enough. There's only 1. And all of my Z's are perfect. So now we're going to take out the perfect stuff. The 2's going to come out and the Z's going to come out. And now I'll see how many there are. So 4 goes into 4 one time. And 4 goes into 12 3 times. And then all of this is just going to stay over here. I'm going to separate it out so you know you can tell that the 4 goes with this. And there you go. There's your answer. So your job, note the time, 10 more minutes, then take the video or get the next handout and move on. All right?